This is a video on determining n for error in the trapezoidal rule. The question states, find n such that the error in the trapezoidal rule approximation is less than 0.001 for the integral from 0 to pi over 2 of the cosine of x dx. So first let's recall the error formula for the trapezoidal approximation. And it looks ugly, but we'll get a handle on it. We know that the magnitude of the error is always less than or equal to b minus a cubed over 12n squared times the maximum of the second derivative of f of x for x between a and b. So a, b, and n, those are all simple. A is 0, b is pi over 2, and n is our question mark. We don't know, but we do want our error, e, to be less than 0.001. So we need to find f double prime of x. Well, f of x is equal to the cosine of x, and the derivative of the cosine is negative the sine of x. So f double prime of x is the derivative of negative sine of x, which is negative the cosine of x. Now we want the maximum of the absolute value of f double prime of x. So the negative doesn't matter. And the key is the cosine of x always lies between -1 and 1. So in absolute value, the cosine of x is never bigger than 1. So we could say that the maximum of negative the cosine of x is less than or equal to 1. So now we could plug everything in. I get that our error is less than pi over 2, because that's b, minus 0, that's a, cubed, divided by 12 times n squared. N is our unknown. We don't know what that is. Times 1 from this maximum value. And we want that error to be less than 0.001. So we just now need to solve for n. So let's clean this up a bit. I'm going to multiply left and right by 12n squared. Since n is positive, that doesn't change the inequality sign. I'm also going to take pi over 2 and cube it. And what I got was about 3.88, that's pi over 2 cubed, is less than or equal to 0.012, that's 12 times 0.001, n squared. So my last step is just to divide by 0.012 and then take a square root. And I arrive at my conclusion that n must be greater than or equal to 18. So in particular, if n is 18, then we're guaranteed that the trapezoidal rule will yield an error in approximating this integral of less than 0.001. And I'm done with the problem.